Hello and welcome to SES Battery World 2022. My name is Mark Newman, founder of Electric Revolution Ventures and Electric Revolution Insights. This is the second Battery World event that we've held on the back of last year's inaugural event. Thanks for joining us today. If you remember last year, SES founder and CEO Qichao Hu released some pretty amazing data on the 4 amp hour cell and a first look at the huge 100 amp hour cell. Recently, SES released some new data on their 50 amp hour cell. And although there is still some way to go, it is clear that SES is way ahead of competitors in the race for next generation high energy density batteries such as lithium metal and solid states. I'm told that Qichao will be providing more updates on their technology today and plans on how to build these next generation batteries at huge scale, including how to solve the supply chain challenges ahead, which are immense. Over the past 20 years or so, I followed deep tech industries such as batteries and semiconductors as an analyst, strategist and investor. And what is clear now is that the electric revolution is now happening, but there is still quite a long way to go. Now, what makes this particularly exciting today, with a huge ramp in demand for batteries and EVs, is the world is yearning for better batteries with higher energy density that in turn allows longer range and less use for critical materials. SES is already well into its automotive A sample with 3 car OEMs, well ahead of any next generation battery company. I will let Qichao explain more details on their progress to date. And now, without further ado, I'd like to introduce the star of the event, Qichao Hu, founder and CEO of SES. Hey Qichao. Thanks, Mark.
Thank you, and welcome to Battery World 2022. This is our second annual event. 2022 was a really difficult year. War, economic uncertainty, COVID lockdowns, and supply chain disruption. And at SES, it was also a really difficult year. We went through a tunnel of hell, but we still made a lot of progress. And today we see a light at the end of the tunnel. Last year, in the first Battery World, we showed the history of battery technologies. And the energy density doubles once every 30 to 40 years. And lithium metal is going to be the next big thing, especially for automotive applications. We also showed how hybrid lithium metal compares with conventional lithium ion and solid-state lithium metal. Conventional lithium ion has low energy density, but then is very mature, is very scalable, and very manufacturable. Solid-state lithium metal promises to have high energy density, but is yet to be proven to be real. Hybrid lithium metal is like if conventional lithium ion and solid-state lithium metal had a baby, and it has the energy density of solid-state lithium metal. At the same time, it has the manufacturability. It shares the supply chain with lithium ion, so it's very scalable. Last year, we also unveiled the world's first 100 amp hour lithium metal cell. We introduced Shanghai Giga, the world's largest lithium metal facility. So, what have we done since then? Well, quite a lot. The progress was really incredible. And our Korea facility in Cheongju, we basically built from a piece of land to the line ready to use in 8 months. And it was really incredible. And then so far, we have built 1,000 of these large 50 and 100 amp hour cells. It was really incredible progress given all the challenges we had. But also, as we built more cells, we realized that we had more and more issues. And these are new issues that we did not encounter before. These are issues that have to do with manufacturing process, equipment design, cell design, testing conditions, material properties, material process optimization. And all these are totally new. Now, we could just cover all these issues under the rug and then continue to build cells blindly. But we decided to slow everything down and then systematically improve everything. Systematically improve and address all these issues. We spent a lot of time understanding where the issues are so that we can solve them. We even design and build new equipment so that we can better characterize and better understand these large cells. We even designed sacrificial robots to do teardowns on these large cells at fully charged state. And all these learnings were incredibly valuable to train our Avatar, this battery health monitoring software. And the accuracy of Avatar on these large cells went from 0 beginning of this year to 60%. And just to give you a comparison, the accuracy of Avatar on the smaller 4 amp hour cells, which we started collecting data and then training the model since 2019, is over 99%. So we're very confident that with more data and then more training, the Avatar on the larger cells will be just as accurate as the smaller cells. And recently, we also published data on the 50 amp hour cells. Last year, we published data on the smaller 4 amp hour cells, and then this year, it's the 50 amp hours. And we have been sharing these data on the 50 amp hour cells with our OEM JDA partners since beginning this year, and this was the first public release. And we're very excited about the data that we were able to achieve with the 50 amp hour cells. It's incredibly difficult. And these 50 amp hour cells have very good low temperature performance. This one shows C/3 discharge from room temperature, 25 degrees Celsius, down to 0 degrees Celsius, negative 15 degrees Celsius, and negative 30 degrees Celsius. They also show very good performance under high power. And this one shows a room temperature and then different power density. C/10, 10-hour discharge, to C/3, 3-hour discharge, 1-hour discharge, and all the way up to 20-minute 3C discharge. And for safety, we send these 50 amp hour cells to third party for safety tests, and we did not experience any thermal runaway under nail penetration, overcharge, external short circuit, or high temperature. And these cells have received UN 30.3 certification. So we just show you some data, but we always love to see some action. And in last year's Battery World, we did a demo with a Gold Card and then smaller 4 amp hour cells. This year, we want to do something much larger. So we partnered with a very cool drone and eVTOL company called Autoflight. And then we put our latest 100 amp hour cells on board. And this is what happened. It's really amazing. And I hope we'll see more of these drones everywhere, making people's lives better. So where do we go from here? One thing we learned in this past year is that to achieve the full-blown specifications that the OEMs require us, we need to control everything. What does this mean? Now, it's not like we want to control everything. We have to control everything. Because if we don't, then we don't have the ability to improve or optimize, or we cannot meet OEM targets. And when I say everything, I mean every material, every process, every step in the entire system. And this everything is basically our supply chain. We need to control our supply chain. Now, it might be counterintuitive for a company in A sample stage to be concerned about supply chain. Well, to us at this point, supply chain is about degrees of freedom. Let me explain why. If you look at our current supply chain, you start with mine and then refining, and then you have solvent additives, and then they form electrolyte, and then separator, and then you have precursors to cathodes, and then anode. You start with lithium ingot, and then eventually you end up with this anode. And there are different ways of making them. For example, extrusion, coating, and PVD. And once you have these four materials, electrolyte, separator, cathode, and anode, then you can build a cell, lithium metal cell. Of course, you also have to design, optimize the manufacturing equipment and the testing equipment. And once you have the cell, then you can build a battery pack. If you add sensors, BMS, and mechanical design for the pack. And then the pack will go into an application device. And then depending on the business model, could be charging or swapping. And then recycling basically closes the loop. And all the data from all the materials, all the cells, the packs, the application, and recycling are collected using this avatar software from mine to man. So this is our supply chain. And then when we are pre-commercial, that means R&D, pre-A, A sample, and B sample. This really means to us degrees of freedom. How many degrees of freedom we have to solve problem, to achieve the targets that the OEMs have set for us. And later, when we become commercial, that means C sample, SOP, and beyond, supply chain means how can we secure supply, ensure quality, and lower the cost. For example, prior to 2015, we only focused on electrolyte. And even though we made a lot of progress in electrolyte, it was very limited how much we could do to improve the performance. And then 2017, we added solvent additives, and we started building our own cells. So we added more degrees of freedom to our capability, and then we could make progress faster. 2020, when we entered pre-A, again, we added more degrees of freedom. We started designing our own manufacturing equipment, testing equipment, and then we added BMS, we added mechanical design for the pack. And now that we are in A sample, we recently added even more degrees of freedom. We brought in-house cathode, anode, and especially in anode, we used to take anode for granted. I mean, it's just a thin layer of lithium. What is there to optimize? Well, it turns out quite a lot. And the existing supply chain for lithium anode is very compartmentalized and very fragmented and very inefficient. And then people do things because of legacy, and people spend a lot of resource optimizing something that should not exist. So we took that in-house, and then we basically changed everything. And we started making this new anode. And we also added a much more sophisticated avatar platform to collect a lot more data and then to process a lot more data. Going forward, when we become commercial, then this degree of freedom becomes about securing supply, ensuring quality. And we plan to add mining so we can secure offtake. And we also plan to add recycling so we can lower the cost. So this is our supply chain. And this supply chain is transitioning from a global supply chain to continental supply chain. And because now we are in A sample, pre-commercial, we are focusing on making things work. And then we are leveraging the existing global supply chain so we can make things fast and then get to commercial stage fast. Now, later on, once we become commercial, then we do plan to build a North American continental supply chain. So finally, 2022 was a really difficult year, and we are going through this tunnel of hell. But then this is a tunnel of hell that every successful battery company and every successful EV company has to go through. There are no shortcuts. And we are reassured in our approach that we want to make lithium metal cells using lithium ion manufacturing process. And we also treat a cell as a system. So we are focused and optimistic that we will see light at the end of the tunnel shortly. So thank you, and thank you for everyone's support.
Hi, next we've got our panel of esteemed experts, and I'd like to introduce our experts, and we're going to have a bit of Q&A looking at some of the stuff that Qichao talked about, and also some of the supply chain challenges ahead of us. So first, I'd like to introduce Tim Gru, who is the Director of Electrification Strategy at General Motors. Then next, I'd like to introduce Dr. Yongjun Zhang. He's a global R&D master at Hyundai Motors. Next, we've got Dr. Josh Fujiwara. He's an expert engineer at Honda's Innovative Research Excellence. We've got Robert Friedland. He's the founder and executive chairman of Ivanhoe Mines and Ivanhoe Electric. Next up, we've got Alice Lei. She's a senior analyst at Tianqi, the big lithium producer. And finally, last but not least, we have Qichao Hu. He's the founder and CEO of SES. Hi, everyone, and thanks for joining us. So to start off, I'd just like to ask all of our esteemed panelists to just respond a bit to what Qichao has just said. How are you thinking also about introducing new technologies to the market, such as lithium metal? So if that's okay, I'd like to start with Tim from GM. Tim, what do you think?
Oh, thank you, and it's a pleasure to be here. So thanks for having me part of this panel. We're very excited about this type of technology and accelerating it into the marketplace. General Motors actually has a dedicated electric vehicle architecture that we call Ultium. And we specifically designed it so it could accept this new technology with minimum disruption to the actual architecture and the manufacturing process, and the ability to get it in as quickly as we can as we expand our scale moving forward. And so we think that we're aggressively pursuing this technology and trying to accelerate it as fast as we can. We think we've proven durability with SES with 150,000 miles demonstrated in the lab. And now we're taking that next step to say, how do we get it into people's hands?
Great. Next, Dr. Josh Fujiwara from Honda. Over to you.
Well, thank you very much for inviting this panel. Honda, like other OEMs, always requires safety, reliability, and low cost. But we think that holy grail of low-cost battery technology is lithium metal anode, and due to high energy density. And most of the latest and most advanced research in the world are papers also focused on the establishment of this technology. And we will continue to collaborate. We are happy to collaborate with SES to bring this goal. Thank you.
Thanks, Josh. And next to Yongjun Zhang. Yongjun, would you like to make some comments on what you saw today from Chichao, and how are you thinking about new technologies such as this?
Okay, thanks, Mark. Recently, SES lithium metal battery technology is developing at a very rapid pace compared to the technology for about 30 years. It is very encouraging that the technology is improving by the manufacturing completeness of a large area 50 ampere hour class high energy density battery. If the stability of this battery is secured by applying AI technology, it will be of great help to the automotive company. From the point of view of application to vehicles, it is very important to secure a pressurization system to control uniformly large area batteries, as well as the long-term stability of high energy density batteries. Yeah, back to you, Mark.
Thanks very much. Robert, would you like to make some comments?
Well, it's been a year since we went around the sun in the first Battery World presentation. Since then, the world has continued to balkanize the world economy. The integrated world economy has broken down, and each geopolitical area is more concerned about their supply chain. So with our 40-year experience in mining, we are looking at the nickel, the copper, the cobalt, and the ultra-pure lithium metal required for the next generation of batteries. So our contribution is to understand the way the technology is going in the future and to get there first and provide the raw material required to get there from here.
Yeah, thanks very much, Robert. Alice, would you like to make some comments from your perspective and from Tianqi's perspective?
Yes, thank you, Mark, and thanks SES for inviting us to this event this year as well. And from our perspective, I was quite agree with what Chichao said in the script, that every player should actually have a great control of the supply chain at each stage. As we know, actually lithium-ion battery supply chain has very stringent product accreditation process. Therefore, it's important that we are taking control of each step of the supply chain to make sure we are producing the reliable and responsible products for the consumers. And regarding the second question of introducing a new technology to the market, and we are quite excited as well, but we still believe that it usually takes a lot of courage and time to introducing a new, especially a disruptive technology like the full solid battery to the market. But we believe it still will take some time to make it commercially into the market. That's basically the idea.
Absolutely, yeah. Thanks, Alice, for that. So I'd like to just talk a little bit more on some of the technologies here. So we've heard a lot from SES in terms of what they're doing in terms of lithium metal batteries. But I'd like to ask everyone here, what new technologies are you looking at in the field of batteries and electrification? New technologies such as lithium metal, but it can be something else, some other battery technologies or other technologies that you're really excited about. Should we go around roughly in a similar order? Tim, would you like to start off from GM?
Sure. And so I think there's several complementary technologies that we're working on to accelerate the introduction of something like lithium metal or other anode type designs. You know, we heard about the need for a uniform stacked electrode with a constant pressure to get the durability and the integration in that, and actually having that complementary technology work with a lithium metal or some other thing is very synergistic on how we move faster, where we don't have to redo the rest of the system or the rest of the vehicle to actually introduce it. And we've got this ability now where, you know, it's a bit of a very positive situation. You know, in the US we call it a blessing, but it's also a curse where we're expanding our capacity. And so as soon as the technology and the manufacturing process and the supply chain proves itself to be lower cost and more capable, we can do it as we expand. And we don't have to worry about retrofitting a manufacturing line or things like that. And it can coexist with other technology moving forward. And, you know, I like to use a term that's, again, a US colloquialism, but it's called cooperation, where we're cooperating to say we can introduce this technology and other technology, and then the competition will be what's best for the customer, whether it be a 500-mile vehicle or a 300-mile vehicle that actually has a much smaller battery pack. And so we're preparing all that adjacent technology so that we can accelerate it into the marketplace as quickly as possible.
Great. Thanks, Tim. And Josh from Honda, what new technologies are you looking at? What are you excited about?
Yes, regarding to this electrified and also carbon neutral technology era, Honda, as I mentioned before, is focusing on safety and reliable and low-cost technology. And we have focused in two major technology trends. One is all-solid battery technology with lithium metal. That is one direction that we are success to realize such safety, reliability, and all low cost at the same time. And another thing is that we are focusing in is pure autonomous driving technology. That will be good for electrified vehicles as well. That's two major things that we are focusing and to realize within this decade, which is until before 2030, we'd like to issue that kind of vehicles into a market.
Great. And I'd like to just ask you, so you mentioned about all solid state, but how would you compare all solid state compared to the approach SES is making with the you know, hybrid or liquid based, more lithium ion like manufacturing process? How would you compare those two technologies?
Well, we are actually doing both technology as simultaneously, and we are thinking about productivity and also reliability. And eventually, we'd like to reduce the price of electric vehicles. That we should focus in the cheaper way. Which one we don't know at this moment, but this technology, which is SES, is to utilize available liquid type LIB technology. Compare with that, solid technology is totally new. That's different things, but we are doing both.
Yeah, newer, so maybe it takes a bit longer, is what you're saying.
I don't know.
Okay, so then let's get some perspective from Hyundai. Yongjun, would you like to give us some of your thoughts here on new technologies you're excited about, what you're looking at?
After all, in order to make a battery with high energy density, lithium metal must be used for the anode. Furthermore, the composition of the electrolyte as well as the lithium metal is very important for high energy density batteries. This is because the long-term stability of the electrochemical redox reaction between the electrolyte and lithium metal anode determines the lifespan of the battery. The types of electrolytes used in high energy density batteries are high concentrated liquid electrolyte and solid electrolyte. As you already know, this high concentrated liquid electrolyte is used in lithium metal batteries, and solid electrolyte is used in all solid batteries. The final goal is to use lithium metal for both cells, but a different approach must be used to ensure long-term durability of the cells. In a lithium metal battery using a liquid electrolyte, it is necessary to induce a stable redox reaction to prevent excessive depletion of the liquid electrolyte and also the lithium metal anode at the interface. On the other hand, in a all solid battery using a solid electrolyte, it is necessary to maintain a continuous close contact with lithium metal and prevent a short circuit of the battery by blocking needle-like dendrite. For these reasons, both electrolytes are very important factors that determine long-term durability in high energy density batteries. In particular, it becomes more sensitive and important in large area batteries rather than small area batteries. We should solve these issues for commercialization of the new batteries. Back to you, Mark.
I like the way you framed it there, because you were framing it lithium metal as the next generation anode, and then you were talking about two different pathways within that, the liquid approach and the solid state approach, which I think that makes it very clear, because I think a lot of people just get mixed up between solid state and not solid state, and they don't actually understand that lithium metal is actually, that's the thing that is the big jump in energy densities coming from the anode, and there are just a few different ways of enabling that, and you talked about them, solid state, and the approach that SES is doing with the higher concentration electrolyte.
Yes, right.
So I appreciate that. So Robert, over to you. What kind of new technologies would you like to talk about that you're particularly interested in here?
We're all about the electrification of everything, which requires us to completely change the way we conceive of and actually mine the resources in the crust of the earth. So since we have a very long lead time in mining and a lot of capital, we have to look forward 5 or 10 years and see where technology is going and what raw materials we'll need. And now that the world economy, which was so beautifully integrated as recently as 2008, is being balkanized, we need to find a lot of these critical raw materials in our own countries. So what's good for General Motors is good for the United States. And we're working now in Ivanhoe Electric in the United States to find all of these critical materials. In Australia, we're building the largest nickel and cobalt resource in the world that's not in the Democratic Republic of the Congo. And working in the United States, we're developing the largest and greenest new copper mine in Arizona. And we've identified very important lithium resources in the United States that can produce lithium metal quickly and efficaciously. So we've been looking at new ways to make lithium metal foil and the types of deposits that will enable us to actually do that. All of these sort of instruments will be part of the orchestra that's required for the United States to have its own secure domestic supply chain for these new technologies. And that's why it's very important for us to be part of this dialogue and see where we're going. And one inescapable conclusion is that lithium metal has the highest energy density on the anode side of the battery. So we will be a very low cost producer of lithium metal and solve part of that problem. For the copper and for the nickel and the cobalt, that's what we've been doing for the last 30 or 40 years. So we intend to make sure that the entire supply chain can be audited, can be very carefully studied, and can be done in a better and more energy sort of responsible way, quite differently from the way mining was performed in the past. And that's our contribution to this effort.
Thanks for that. Yeah, totally agree. Lithium metal is enables by far the highest energy density on the anode side. And as you said, that's one of the, being able to make it in mass production at low cost is still one of the big hurdles to mass production. So I think that's really great what you're looking at there. And I think actually it's a very similar topic here for Alice. Over to you from Tianqi. You're also a lithium producer, so perhaps you could tell us what new technologies you're looking at and maybe comment on some of the lithium metal stuff we were talking about earlier.
Yes, From our perspective, as an upstream player in the supply chain, our focus would be more on the lithium-related materials innovation, as we have 30 years expertise and experience in the lithium industry, and we mostly have the lithium business as our core. Therefore, we mostly focus on the lithium-related material innovation, such as the lithium sulfate and lithium metal. Of course, that's why we invested SES. We are trying to work with them, work with the downstream battery cell makers to make sure what kind of lithium materials they want. So we are customize that kind of material for them to be applied, used in the battery cells. Therefore, that's probably what we are focusing on.
Great. So is lithium metal a big part of Tianqi's strategy to be a lithium metal foil supplier as well? Yeah,
sure. I think that, as what Robert has said, that lithium metal has already been the industry consensus that lithium metal would be hugely applied to use the solid battery in the next battery generation technology.
But great. I think, Chichao, I wonder if I could just bring you in here before we go to the next question. Just get a chance, because you haven't had a chance to talk yet on this panel. You heard of lots of comments here on different next generation technologies from all of these different car OEMs, GM, Honda, Hyundai, Ivanhoe, Tianqi. Just, any thoughts from what you've heard today?
Yes, so I think first of all, really appreciate all the panelists participating and then supporting us. And then it's been a year, so it's good to have everyone back. On the new technology, really, I think it's about the whole system. And then, like Tim mentioned, at the end of the day, this cell needs to be integrated with the pack and then the car. And then there's a pressure system, the pack, the software, and then, like Robert and Alice mentioned, the upstream materials. So really, it's a system. It's not an individual electrolyte technology. It's not an individual anode coating technology. It's not going to be an individual technology or a collection of individual technologies that's going to change the world. It's really has to be a system. And then part of this is existing mature technology, optimized. Part of this is totally new, but it will really have to be a system that we need to develop and then have this entire new system to really change the world.
So it's an entire orchestra, not just the solo, is what you're saying. Yeah. So that's great. So I'd like next to switch topics to the supply chain. So we all know the huge supply chain ramp required in order to electrify all of cars, and all of transport was even greater problem. Considering that huge problem ahead of us, how are you all dealing with this? And particularly considering all of this new complication with new technologies that are being introduced, such as lithium metal batteries that we just talked about. And in addition, considering this new complexity that Robert brought up, which is this new kind of, relatively new, complex geopolitical environment and balkanization or decoupling of supply chains that we're starting to see happen now. So Robert, since you brought it up, maybe I just throw this to you first to start, if that's okay.
The world's changed. We have tremendous pressures, and everybody knows the trends. We have the United States government has said that silicon chips made in the United States can't be sold to China, for example. Every action begets an equal and opposite counter-reaction. And so American automobile manufacturers have to worry about their supply chain. Chinese automobile manufacturers have to worry about their supply chain. The Korean manufacturers have to worry about their supply chain. The Japanese also, the Europeans. And so this has thrown an extra spanner in the works. A lot of the inflation that we're seeing in the world economy is not really coming from the demand side. It's easy to suppress demand when the Fed raises interest rates. Most of the inflation is coming from the supply side. When you balkanize the world economy, you stress the integrated world economy on the supply side. And that means that the critical raw materials we need to enable this energy revolution become even more important. And that's why we call this the revenge of the miners. The quantity of these metals that we need to stop burning hydrocarbon and coal are enormous. And they have to be supplied with highly scrutinized supply chains, very clean, very dependable, and very high quality raw materials. And so this is going to be a big challenge because the demand is like trying to get the contents of the Hoover Dam through a garden hose. You've already seen a big jump in the price of lithium in the last time we went around the sun, and big jumps in the price of nickel the last time we went around the sun. So our job is to find these raw materials, and in the case for General Motors in the United States or in Australia or in Canada, to make sure that we can supply this raw material to the American automobile industry. We have to live with the world as it actually is. And so it's going to make it a little harder, but if you want to change the world and you want to save the planet and you really want to make a difference, nobody said it was going to be easy. It's hard to make history, but this group is in the process of doing it. It takes a visionary like Chi Chao to be very forthright about how many individual challenges have to be overcome to win this battle. This is the company that's actually going to do it, if anybody's going to do it. We looked at all of them when we had our SPAC. Mark, you and I worked together, and we looked at the entire battery industry, and we saw a lot of claims with competitors that were absolutely bullshit, frankly. This company is honest and is directly, publicly disclosing all of the key numbers on the way to the revolution. And the shareholders, the stakeholders, are an interesting combination of upstream suppliers, like a Chinese lithium producer, or ourselves, who produce nickel, copper, cobalt, other metals, and major international automobile manufacturers. And we're coming together in a way that hasn't happened since the Iron Horse required iron and hydrocarbon to start when Henry Ford started mass producing the automobile. So this is it, unfolding in real time. The miners are super important. Government support to the miners is super important. We now have the so-called Inflation Reduction Act in the United States to help people like us find the raw materials in the United States to support this transition. But a lot of the technology is in Japan. A lot of the technology is in Korea. A lot of the technology has come from China. And that's why I do think we're better off cooperating globally than just tearing ourselves apart into disparate little pieces. The world needs to work together, because if we're going to have a new way of transporting the automobile industry that's clean and green, we have to work together. And that includes the miners. So on behalf of the mining industry, we're here and we're up for the challenge.
Great, thanks, Robert. From one miner to another, from Ivanhoe to Tianqi, Alice, would you like to talk about how you're seeing the challenges ahead in the supply chain?
Yes, actually, I think the coming out with the IRA has already putting out the fact that the whole global supply chain is shifting. We are believing that the globalization supply chain that has been built in the past decades will probably change in the next few decades to be more localized at the major consumer market, such as localized in the US, the European, and the Asian markets, as the IRA has already clarifies that most of the critical minerals and materials should be produced or assembled at the US. Therefore, we think it's a trend that in the future, maybe European will have their own battery act to have the same kind of behavior. Therefore, as what Robert has said, as a mining company, maybe we also have some leasing chemical business, but as a very upstream player, for us or as a corporate, it's important to choose our next location of expansion to comply with the trend, comply with the flow of the geopolitical tensions.
Okay, thanks, Alice. Let's hear some thoughts from some of the automotive OEMs. Tim, some comments from you on how you're dealing with this supply chain ramp and all these complexities?
Yeah, absolutely. I'd like to start off with, I really resonate with what Robert said, where, we can do this and we can get through it together. I think Xijiao talked about the tunnel of hell to get to heaven as well. And we just see it as the tunnel to heaven, and it's coming. So we get through all of this transitional time as quickly as we can. And so from a raw material point of view, we have binding agreements to secure all the raw material we need for 1 million vehicles annually in North America by 2025. And expanding that, we recently announced that we're on track to get 5 million vehicles annually by 2030. And so the minerals are there. And like Xijiao said, it's all about the entire system and the entire manufacturing process and how do you do it at low cost to tie it all together. And that's the tunnel that we're operating in right now, to say, how do we make all that achieved so we can get to this heaven moving forward? And even beyond the cost and the material processing and great discussions on electrolyte and everything matters, it's then, well, how do you make the most of it once it's in the vehicle? And so how do you do the total life cycle, the circular nature of these minerals? And we talked about the data farm and the ability to track this and then get into recycling. And while you're actually doing this expansion and this scaling right now, how do you make sure that you have the information so you can optimize the future when it gets to recycling? And so, securing the base materials is well underway, 1 million to 5 million. In this decade, getting all the rest of the system where that lithium metal and the foil can turn into a cell factory and an anode line, and then it can be integrated into a cell assembly and into a vehicle assembly, and then into a data stream where we make the most out of it at every phase of its life, and then bring it back in recycling is where we're at. And so we think we have the binding agreements. These are not MOUs or non-binding agreements. These are binding agreements to get the base materials that we need when we need them. Now, how do we make it so that it's actually got the higher performance, higher energy density, and the information to last the life of the product?
And how much do these political uncertainties drive decisions for, say, location of your supply chain? Because the fact of the matter is, most of the supply chain today is coming from China, or it touches China, goes through China in some way, processing or mining or some part, cathodes, anodes, etc., batteries themselves. Majority is actually going through China in some part. So how much of a big concern or part of your decision-making process is that?
So I think other panelists talked about it very well, right? There's going to be, as we expand into this light-duty, high-volume application, there's going to be a natural localization. That's true for anything that we do in a high-volume automotive business. And now having some of these accelerants, right? We talked about the Inflation Reduction Act or some of these other moves by the miners to actually have it become more local where the people use the product, and then we can have that whole ecosystem develop, is accelerating it. We always, one of the most important things in high volume manufacturing is securing stable supply, and that's always high value to us. And so that's fundamental in our business model to say, whether it's local or whether it's a friendly country or whether it's a more difficult supply chain, how do we make sure we never get a production interruption? And we have numerous amounts of processes and contracts to make sure that happens.
Thanks, Tim. Josh, how are you and how's Honda thinking about these challenges ahead?
Yes, basically our principle is localization. From the beginning, last century, we built a factory in the United States. Then basically, we are not exported from Japan. Always we build the factory and also the supply chain built in the local. So I think next electrify also the same trend and same way, we will do the same way. And especially where Honda is focusing in the two major area for the electrified and also the sales in the US and China. Both has a different, actually different, and we need to establish different supply chain individually. So in particular, due to IRA, the Honda seek to establishment of the supply chain in North America is very important things and urgent issues. So that we as Chicho mentioned, that to control or to integrate all the supply chain in local is pretty important. That we believe. Thank you.
Thanks, Josh. Yongjun from Hyundai. Any thoughts from you on this topic?
It is not an easy issue for supply chain, but we should work through it together. From the automotive company's point of view, there is an example of recycling of waste batteries. Many companies in the world are interested in recycling waste batteries in order for recycling companies to increase their profit. The supply of waste batteries still needed to increase more. During that period, recycling technology of waste battery needs to be further matured and stabilized. I think this method seems to be able to serve the supply chain to some extent.
Thanks very much. And then finally, Chichao, we've already heard some of your thoughts during your keynote, but would you like to add something? There's been quite interesting discussion here, I think, from these panelists. Anything to add from you?
Yes, I think the first part, in terms of ramping up supply chain for new technology, for our lithium metal, it actually shares a lot of the supply chain with lithium ion. For example, the cathode, the manufacturing process, all that is the same. And there are parts that are different. For example, this lithium anode, and then the current supply chain for lithium anode is very compartmentalized and then very fragmented. You have several companies involved, and then cost, process, all that are just very inefficient. So we are working with our partners to basically try to make that process as possible, from the mine to the final anode, as simple, as streamlined, as optimized, and then as fewer players involved as possible. And then I think that could be a really key factor to ramp up the supply chain for lithium metal batteries. On the second part, on the geopolitical issues, so currently we are pre-commercial, and then we are working with this global supply chain, as we all see on this panel together. And then, like Robert mentioned, things are so much easier, and then we can do so much more when we work together. Now, we also do recognize this manufacturing renaissance in North America, and then North America does have a lot of potential for a lot of these manufacturings. Abundant raw materials, fairly low cost electricity, and then access to well-trained labor, high technology. So we are preparing to actually build this entire supply chain, and then help build this entire supply chain. For example, electrolyte, anode, cell in North America. It actually, this trend offers a lot of opportunities.
Exciting stuff. Well, I think we're just about out of time. So I think we've had a great discussion. We talked about some of these new technologies, and we talked about these huge contentious topics of the supply chain, including the political uncertainties ahead of us. I think I'd just like to thank all the panelists for joining. Tim, Yongjun, Josh, Robert, Alice, Chichao, thanks all for joining. It's been great. Thanks for your time. Next, what we're going to do is we're going to have a live Q&A where you get your chance to ask a question directly to Chichao. But just thanks again to all the panelists. Thanks for joining, and I hope you can come back for our next event. Thanks, everyone.
Great to be here.
Thank you.
Bye-bye.
Bye.
Oh, hi, everyone. So now we're about to begin our live Q&A, where you'll have the opportunity to ask a question live to Chichao Hu, founder, CEO of SES. You can type a question in comments on YouTube. And for those questions, there's one or two other questions that were for other panelists. We'll pass them on. These questions are specifically to Chichao. See a few questions coming in. So I'm just gonna start off by just asking one of my own questions. Chichao, so there's been a lot of progress since we did this about a year ago, but you've mentioned several challenges you've had along the way at your keynote. So what would you say is the #1 challenge remaining before you can move to the world's first mass production of lithium metal batteries?
Yeah, thanks, Mark. I think, well, we have thousands of challenges, thousands of issues. I would say probably the biggest one is it's really hard to make these cells. And then the large 100 amp hour cells and the large 50 amp hour cells, it's really hard to make them. And then it's one thing to make one, and then you have to make a 0.3 cell per minute, 0.5 cell per minute, and then 1 cell per minute, and then 5 cell per minute, and then 10 cell per minute, and then eventually even faster. And then when you do that, there are lots of challenges. Now, the good thing is that a lot of these challenges are similar to what the industry went through in lithium ion. So a lot of these challenges are not unique to us, and that's a good thing. It's a good thing that we are building lithium metal cells using lithium ion manufacturing process so that we can learn from all the experience in lithium ion. And now, also some challenges are very unique to lithium metal. For example, this anode, and then this wide format lithium metal anode, and the cell is almost 600 millimeters wide. No one in the world has figured out a way to make this wide format thin lithium metal anode in a consistent way, ensure quality. So we went through a lot of challenges trying to improve that. And then once you have this lithium metal foil, how do you process that? You can't just cut it with standard techniques that people use to cut graphite or silicon anode. So lots of unique challenges that arise because we're using this wide format thin lithium metal anode. But we are addressing those, and also we are also taking all the experience learnings from lithium ion. So I think we can solve these issues and then make a lot more progress.
Great, thanks. There's a question here from Tom Johnson. Chichao mentioned several types of lithium metal, such as PVD or other. Do you expect to be using lithium metal foil, or do you think SES will eventually use other forms? For example, lithium-free anodes?
Yeah, we are working on lithium-free anode, but then for automotive applications, our main anode currently we have lithium. And then the pure anode-free anode, which is a subcategory of lithium metal anode, we are developing that, and then we can use that for some niche applications. For example, some drones applications, some aerospace applications, also using that together with a lower energy density pack, and then basically this dual pack approach. So we are looking at anode-free, but for now, our core platform will have lithium metal anode.
Great. Another question here from Yunya Zhang. When seeking lithium metal batteries, people often worry about their safety. How do the panelists, or how do you, Chichao, think about how to overcome customers' concern about lithium metal battery safety?
I mean, safety has been a concern for lithium metal for a long time. And then we first want to quantify that. What does it mean? And then what tests we need to do and the OEMs need to do to pass their bar for safety. So we need to first quantify that. It can't be just some vague philosophical thing against lithium metal because of safety. First, we have to quantify that. And then once we quantify that, and we know exactly what tests we need to run, then we do the test, do the experiment, collect data, and then see where we are, how far we are, the gap. And I think we can solve the safety problem. The materials that we're using, the high concentration electrolyte, and also the coating on the anode, these are much safer than the older materials using lithium metal. Also, the application of software. For example, in the past, the smaller 4 amp hour lithium metal cells, we've really improved the accuracy of the smaller cells from really nothing to now 99%. And then these larger 50 and 100 amp hour cells, because we just started collecting data earlier this year, we've also improved the accuracy from 0% now to about 60%. And there's a lot of more improvement coming. So I think we can use a combination of improvement in the material as well as application of very advanced physics-based model, as well as machine learning based algorithm to really develop a very accurate prediction mechanism so that we can actually predict incidents before they happen. So I think so safety cannot be a vague philosophical thing. It's going to be quantified, and then we collect data, understand the gap, and then we figure out how we can close the gap.
Great, thanks. There's quite a few more questions coming in, so please we'll do as many as we can. Question here from Xing. Chichao, can you share some specific examples of the issues that you faced that caused the tunnel of hell in 2022?
I mean, there's so many, right? So, for example, our anode is lithium on copper, and then to punch it into the electrodes, initially we use laser. And then, so we use laser because laser is flexible. You can adjust the dimension fairly easily. But then when laser cuts this electrode, it will melt lithium, and then also it will cut the copper and then create a lot of copper powder. So these powders will get trapped in the cell. And then you wouldn't have this problem in lithium ion, at least to a much less extent. So then we had to figure out how to modify this anode punching machine, and also in the process of between connecting the anode punching and the stacking, so we can remove all the copper particles. This was one challenge. Others, for example, we use so we do electrolyte filling. We fill these high concentration electrolyte into the cell, and the cell is much larger. So we really struggle trying to fill the electrolyte in a uniform way. And the cell is just so large, and the electrolyte will not soak, and it wouldn't be uniform. And then also pressure. So the pressure value that we apply between the large 50 amp hour cell and the smaller cell is about the same. But then because a larger cell, the area is so much higher, it's much harder to design this testing jig that can apply the pressure in a uniform way. So tons and tons of issues like that. But most of them we can solve by leveraging the experience in lithium ion, and then some are unique, and then we are working on solving those in-house, and those are quite interesting problems.
Great. You actually just touched on this, but the specific question on the pressure from Marco Sinishalshi, I hope I got his name right. What is the pressure at which SES 50 amp hour and 100 amp hour batteries have been cycled?
I believe it's around 50 psi, the pressure value. So that's the value, and of course, I think that's about 3 to 4 atmosphere. And then so that's the value. But then how do you apply that value uniformly across that big cell? That's very challenging.
Next question from Catherine Herr. Hi, Catherine. Great example showing SES battery on auto flight. How do you see the adoption progress on eVTOL versus EVs for SES? And how about the performance of lithium metal anode versus silicon anode on eVTOL applications? It's a tough question.
Well, the first one I'll answer. So obviously we have 3 JDAs with EV companies, and then we are focusing on that. But eVTOL is actually super cool. And then because EVs, they care more about watts per liter, volumetric energy density. And then lithium metal is higher than silicon in watts per liter, but not that much. And then eVTOL cares about watts per kg, gravimetric energy density. And then lithium metal is much lighter than it is smaller compared to silicon. So we're really excited about eVTOLs. And then within eVTOLs, Autofly is one example. We're also working with a few other eVTOL companies. And then we think lithium metal may actually become commercialized in eVTOL first. And of course, within eVTOL, you have manned and unmanned. So I think for unmanned package delivery using eVTOLs and drones, I think that we'll see lithium metal commercialization probably first, and then manned EV, and then eventually manned eVTOLs.
Okay. Actually, the second part, no, actually, I think you answered both parts of that question. Okay, great. So let's move to the next question from Matthew Bird. What is the recyclability of a lithium metal anode? Better, worse, or about the same as lithium ion battery cathodes? I guess you mean anodes, because lithium.
Yeah. Yes. So if you look at a lithium metal cell, most of that is actually the same as lithium ion cathode, electrolyte anode. Cathode electrolyte separator, same as lithium ion. The one part that's different is the lithium metal anode, and then we are developing a technology to recycle lithium metal anode. We think lithium metal anode should be easier to recycle than a graphite or silicon, because for lithium metal anode is lithium metal anode, and then you just basically get it back to lithium metal anode, whereas graphite silicon, the structure gets destroyed and you have to reform the structure. So lithium metal anode, we expect should be easier to recycle than lithium ion anode.
Got it. Next question is from Kevin Rhodes. What technologies are you looking at for pairing with the lithium metal anode on the cathode side for next generation cells? I guess you've mostly addressed that already, but perhaps you could just answer specifically that question.
Yeah. So for lithium metal anode, we are looking at 2 categories of cathode. So one is high nickel, which is used for premium applications, EVs and eVTOLs. So these are high nickel NCM, NCMA, these type of high nickel cathode. But also we're looking at LFP or some version of LFP combining with lithium metal. that'll be for the economy version.
Okay, I think we've got time for maybe one more question. So question here from Joan de Dobler. Sorry if I mispronounced your name. Do you plan to also invest in nickel, cobalt cathodes, and raw materials mining? So I guess the question is, are you looking to also invest upstream in the cathodes and raw materials and the metals as well?
Yeah, we definitely want to secure our entire supply chain. And then, as mentioned earlier, for us at this stage, it's about degrees of freedom. And then by having access to more different varieties of cathode that actually help us improve and have a deeper understanding of the electrolyte and anode and the whole cell system. So yes, we will. And then we do have plans to partner with companies upstream in lithium mining, refining, and also cathode precursor production. Yes.
Okay, great. I think we're just going to go to the final question here, because we are running out of time. From D-Raz, what quality tools and testing mechanisms do you use to screen for battery degradation and lithium dendrite shorts?
A lot. We have a very comprehensive set of tools, but also process, and all the way from materials testing, cell testing, small cell, large cell in a pack, and then tear downs, quite a lot. And then we also collect data from all these instruments, and then we feed these data to the avatar, the safety software, to train the safety prediction software. So quite a lot. And I think we probably characterize, I would say, almost every aspect of the cell.
Great. Well, I think that's about it. I'd like to wrap up here. That's it for this year for Battery World, SES Battery World 2022. I'd like to thank everyone for joining. This is the second event of SES Battery World. And we're planning to do another similar event end of next year. So I hope you can all join us again then. And so thanks from me, Mark Newman. You can contact me if any questions at mark@electricrevolution.info, info. And I will try my best to get back to you. But finally, I would just like to hand over to Qichao for some final comments. Qichao, over to you.
Yeah, again, thanks to everyone for attending Battery World 2022. And 2022 was a really difficult year, not just for SES, but I'm sure for everybody. And then this year, we really started down this path of building these large lithium metal cells, 50 amp hours and 100 amp hours. I believe they are the largest lithium metal cells out there. And then we went through a lot of challenges. And I think it's a good thing. Looking back, it's a good thing. These challenges are basically, we have to go through these challenges to get to the next step. And then most of these challenges, we can leverage the experience from lithium ion. And this is why from day one, we built lithium metal cells using lithium ion manufacturing process. We keep stressing that. And if we don't do that, I think it'll be much harder for us to solve these challenges. So we are reassured in our approach of building lithium metal cells using lithium ion manufacturing process and leverage as much of the lithium ion supply chain know-how capability as possible. And I think in the next 6 months to 1 year, I think we'll have lots more exciting progress to share with everyone. So thank you all.
Thanks, everyone. See you next year.